Hi everyone, I'm Snoddy, and today I'll be talking about a project I've been working on with Ken Kurtz titled Comparison Promotes the Spontaneous Transfer of Relational Categories. Categorization is an important cognitive capability as it allows us to summarize like instances in a single representation and generalize that representation to new situations. Extant category learning research has largely focused on attribute categories which are characterized by intrinsic featural similarity. For example, the concept of bird is associated with features such as having feathers and wings. As much of our conceptual knowledge is thought to be relational in nature, it's important to understand how relational categories work. In contrast to attribute categories, relational categories are characterized by extrinsic similarity in relational structure. So for something to be classified as a member of the carnivore category, it has to abide by the relational structure of an organism that eats meat. Given that relational categories are not bound to a single stimulus domain like attribute categories are, they are capable of being generalized to multiple domains as long as the underlying category structure is pertinent. This cross-domain generalization of relational categories is similar to analogical transfer, which refers to our ability to take knowledge that we've acquired in one domain and apply it to some other content domain. An analogical transfer has historically been studied via the problem-solving approach of Jick and Holyoake. In this procedure, participants are given a base passage to study that demonstrates a relational concept. In a subsequent task, participants are given a problem to solve, and the critical question is whether participants will demonstrate the concept from the base passage when solving the problem. And the common finding is that when this problem-solving task is administered spontaneously or as separate experiments for each phase, there's a relatively low rate of transfer success. This highlights that the main difficulty in transfer is spontaneously accessing germane but superficially dissimilar prior knowledge from memory. By providing a hint that these two phases are related, it attenuates this access demand and makes transfer more likely to occur. So in our submission to last year's conference, Ken Kurtz and I asked whether relational categories were amenable to a process like spontaneous analogical transfer, and whether we could assess spontaneous analogical transfer by using category learning tasks. So we proposed the new procedure for assessing transfer, where we operationalized it not as a problem-solving task, but as using the knowledge acquired during one relational category learning task to enhance the learning of the same category structures when they're presented in a new domain. And such a categorization-based procedure moves beyond the conception of transfer offered by problem-solving tasks to highlight the importance of using what we already know to help us learn about something new. As prior relational category learning research has provided evidence of the queued transfer of relational categories acquired in one domain to increase the ability to categorize items presented in another content domain, similar to hint-aided transfer in the problem-solving approach, and our novel assessment maintains the core cognitive processes involved in spontaneous problem-solving, our first hypothesis was that relational categories acquired during a base category learning task would be spontaneously accessed during the target category learning task and transferred to facilitate performance. As attribute category learning research has often used recognition memory measures to assess representational claims, we included a recognition memory phase in our procedure in an attempt to understand the type of representation or processes that would underlie transfer success in this paradigm. As prior attribute category learning research has demonstrated that acquiring a category structure affects recognition memory performance by increasing both hits and false alarms relative to non-learned categories, our second hypothesis that we tested was whether acquiring a relational category would demonstrate a similar effect. So in other words, a relational category would increase both hits and false alarms on a subsequent recognition memory assessment. In Snoddy and Kurtz 2020, we found evidence of transfer in our category learning condition that underwent spontaneous transfer, which provided evidence that relational categories are amenable to spontaneous transfer, and it also provided evidence for the construct validity of our novel procedure to assess spontaneous transfer. In contrast to the expectations set up by the problem-solving approach, we failed to find evidence of transfer in our category learning condition that underwent hint-aided transfer. We also found that a prior category learning task led to an increase in false alarm rate, but not hit rate, on our subsequent recognition memory assessment relative to our no-learning baseline. And our interpretation of this effect suggested that schema abstraction may have been a common mechanism in the effects of category learning on recognition memory and the spontaneous transfer of relational categories. So in the present study, we sought to further explore these two hypotheses with respect to comparison-based encoding. Comparison has been demonstrated to improve spontaneous access of knowledge by supporting schema abstraction at the time of encoding, and in the relational category learning literature, comparison has been demonstrated to result in improved queued transfer relative to category learning tasks involving single item presentation. However, Patterson and Kurtz have demonstrated that the benefits of comparison may depend on the nature of the category learning task that it's administered with. So Patterson and Kurtz found a benefit of comparison when combined with observation, but not classification. So taken together, these findings suggest that comparison, at least when combined with an appropriate category learning task, should improve the spontaneous transfer of relational categories, and if transfer and recognition memory effects observed by Snoddy and Kurtz 2020 were both driven by schema abstraction, comparison should also increase false alarm rates relative to single-item tasks. So in the present study, we manipulated the base category learning task that participants were assigned to either comparison, single item, or our no learning baseline to test our two hypotheses. And the general prediction here was that the degree to which a base category learning task provides support for schema abstraction should affect both transfer and false alarm rate. So concretely, we predicted that the comparison tasks should produce the highest rate of target category learning accuracy and false alarms on the recognition memory test. The single item task should produce a moderate rate of accuracy and false alarms, and our no learning baseline should produce the lowest rate of accuracy and false alarms. We adapted the category structures and stimuli from previous work. The stimulus set consisted of 3 mutually exclusive category structures that demonstrated the relational concepts of support, a monotonic decrease in height, and symmetry, where 2 elements from the array that were similar in size, shape, and color were stacked atop another. To create a situation for transfer, each category or structure was instantiated into a rock and mobile domain. In support of our spontaneous transfer manipulation, we created 2 distinct category labels for each category structure within each domain. We employed the procedure of Snoddy and Kurtz 2020 to test our 2 hypotheses concerning recognition memory and transfer. During the base category learning training, we manipulated the task that participants received, either observation with a single item presentation, observation with comparison of items from the same category, classification with comparison of items from the same category, or a baseline condition that did not undergo the base category learning phase and started the experiment during the recognition memory phase. Participants assigned to a category learning condition completed 3 blocks of supervised training in their respective task. As the observation conditions do not provide any overt responses during training as a measure of accuracy, we include an old item test to assess mastery of the category structures at the end of the base category learning phase. The recognition memory phase was divided into study and test. During study, participants were told that they were starting the memory phase of the experiment and were then sequentially presented with a novel category-consistent items for self-paced study. Immediately after the study phase, the recognition test was administered. The test included items from the study phase's old items intermixed with novel category-consistent lures, and participants were asked to make a yes or no judgment for each item about whether they remembered seeing it during the memory phase. After the recognition memory phase, participants proceeded to the target category learning phase. Here we induced a context shift from the base category learning phase to limit the retrieval cues provided by the task and to mimic the access demands involved in the spontaneous transfer version of the problem-solving approach. This was done by presenting the target category learning phase to participants as a new experiment, and in support of this manipulation, changing the color scheme and font that was used in the task. We also implemented the category structures from the base category learning phase into a new stimulus domain and provided a different set of category labels. As we manipulated the base category learning task that participants received, we followed from previous work in using a condition-neutral endorsement task during target category learning. So during endorsement, participants are shown items that are randomly paired with a category label, and participants are prompted to evaluate the accuracy of the item label pairing. And it's worth noting that in the present experiments, participants must now transfer their knowledge over both stimulus domain as well as task, which creates a more challenging transfer assessment than the one that we used in Snoddy and Kurtz 2020. Participants underwent 6 blocks of supervised training in this endorsement task, and we manipulated spontaneous and hint-aided transfer phases to try and better understand the role of providing a hint on target category learning accuracy. So we used a more direct hint than what we used in Snoddy and Kurtz 2020, and during the hint-aided transfer phase, we provided a reminder of the hint on each trial. We manipulated when the hint-aided transfer phase began between conditions. So participants in one of our 2 observational comparison conditions received the hint at the beginning of the target category learning phase, whereas the other observational comparison condition, as well as classification comparison and observation single item condition, started off the target category learning phase with a spontaneous transfer phase, and at the beginning of block 4 received the hint. So here are the results from the base category learning old item test. Here we had no a priori predictions, but any differences between conditions in the quality of initial learning could provide an alternative explanation for our results in the subsequent assessments. I'd just like to briefly highlight here that we found no significant differences between any of our category learning conditions in performance on the old item test. Here are the results from our recognition memory test. Looking first at the false alarm rates on the left-hand side, in support of our predictions, we found a significantly higher rate of false alarms in all of our category learning conditions relative to baseline. In contrast to our prediction, we found that the comparison conditions did not differ in false alarm rate from the observation single item condition. Our analysis of hit rate in the right panel was largely exploratory, but based on the attribute category learning experiments, we might expect to see an increase in hit rate in the category learning condition relative to baseline. However, we did not find this, and we don't see that any of our category learning conditions increase the rate of hits relative to baseline. Looking next at the results from our target category learning phase or a measure of transfer. Our primary question here concerns spontaneous transfer performance, so we're looking first at target category learning accuracy in the first 3 blocks of trainings for our participants undergoing the spontaneous transfer instructions. In partial support of our predictions, we found evidence of spontaneous transfer in our comparison conditions relative to baseline, evidence via improved accuracy in the early blocks of trainings. We found no difference between classification and observation-based comparison. In contrast to our initial predictions, we found no evidence of transfer in our observation single item condition relative to baseline. Our next 2 analyses were exploratory and sought to test whether we would see evidence of the provision of a hint, leading to improvements in target category learning accuracy. The first analysis compared our 2 observational conditions that were undergoing either spontaneous or hint-aided transfer during the first 3 blocks of this phase. We found no difference in performance between our 2 observational comparison conditions, and we did find the same transfer effect in the hint-aided observational comparison task relative to baseline. So this tells us that the hint doesn't seem to be detrimental or helpful to performance. The second analysis compared conditions that received the hint in the middle of the target category learning phase. And the only finding of note here was that performance in all of our conditions appeared to plateau during these blocks, except for in the observational comparison condition, where the provision of a hint at the start of block 4 appeared to enable continued learning during these blocks. And this was significant relative to baseline and a marginal effect relative to classification comparison and observation single item. So our predictions concerning analogical transfer were largely supported. We found evidence of spontaneous transfer in our comparison conditions, but not in our observational single item condition relative to baseline. As we used a more difficult transfer assessment that increased access demands by requiring participants to transfer the category structures across both task and stimulus domains, this pattern of results is largely consistent with similar manipulations in the problem-solving approach. So under a more difficult transfer task, comparison seems to be required for transfer effects to emerge. Our results were also partially consistent with experiments exploring the queued transfer of relational categories. We found a benefit of comparison, but not single items, during our spontaneous transfer phase, which is loosely consistent with finding a benefit of comparison relative to single items in queued transfer experiments. However, the lack of differences between classification and observation comparison tasks in the present study appears inconsistent with the results of Patterson and Kurtz. As the present study failed to find differences in initial learning between these conditions that Patterson and Kurtz found, it may reflect a boundary condition on the benefits of observational comparison. So when classification comparison condition achieves a comparable level of mastery of the category structures during initial learning, then we may not expect to see differences on our subsequent assessments like Patterson and Kurtz found. We also found limited evidence of hint improving transfer via continued learning in the observational comparison condition when the hint was administered in the middle of learning. So a key question for future work to explore is whether the hint is just less effective in this categorization-based procedure, or if we're just not setting the hint up in a way in which it can be effective. Our recognition memory results were inconsistent with our second hypothesis. Comparison did not increase false alarm rate relative to the observational single item task, and this finding suggests that the support provided for schema abstraction during initial learning does not affect subsequent false alarm rates. However, the present results do affirm that prior category learning experiences, regardless of the task, does appear to influence false alarm rate. So a key question for future work is to try and better understand the mechanism of this effective category learning on recognition memory, and whether it's something more basic than schema abstraction, like a sense of structural similarity. So that's the talk. Thanks for attending. If you have any questions, feel free to reach out to us via email.